All right, welcome back, guys. So today in this lesson, we're going to move on from graphing, and we're actually going to talk about something a little different. We're going to be talking about exponential growth versus exponential decay. So everything that you graphed on the pieces of graph paper, and then when you did the bookwork, hopefully you were starting to see that sometimes these pictures start off really small and then they grow really fast, and then sometimes they start and they're decreasing as time progresses. So if I want to go ahead and start, I'm going to skip the vocabulary words and the examples for just a second, and I actually want to start with the pictures, because if you can recognize growth and decay just off of a picture, then you'll be perfectly fine. I'm going to show you how to do these without a calculator, and we're going to look at some formulas, we're going to look at some key differences, but honestly, the main thing that I need you guys to understand from this video is the difference between growth and decay in a picture. Right. So if you look at this example right here, I copied this off of the Google, and it is exponential growth. And as you can see right here, it says that for exponential growth, the improvements come slowly in the beginning, but your gains increase rapidly over time. So let me try to summarize that for you guys. That's fancy. So this is the results. So this is any number, anything that we want. The x is usually time in this problem. So as time increases, our initial amount is slowly increasing. It almost looks linear, to be honest. But then as time progresses, it starts getting larger and larger and larger. And then it gets large so fast that it basically runs off of the graph. And yesterday when you were doing, or on Friday when you guys were doing the bookwork over the graphing, hopefully you saw that a lot of times you couldn't graph all 5 points because they went off of the page so quick. So there's exponential growth. It starts all small and then gets larger very fast over time. Okay. And this picture right here is exponential decay. All right. And we all know that decay means decreasing or dying or getting smaller. So the initial amount starts off really large and it looks like it's decreasing at a very fast rate over time. And then as time progresses, it looks like it starts slowing down, and it's going to slow down, and the amount that it decreases is going to get very small very quickly, just like that piece of paper that we cut, the size of the paper. Okay. And then as it approaches 10, it looks like it's getting closer and closer and closer to 0, but we're smart enough to know that it will never touch 0. Okay. So there's the two pictures. Now we're going to go back and we're going to take a little bit of notes. If you wanted to sketch those pictures in your notes, you're more than welcome to, but the main thing that we need to have in our notes is going to be on this slide right here. All right. So here's your vocabulary words. We have exponential growth and exponential decay, and we kind of talked about the differences already between growing and decaying. And so here's the formula that we've been using. Okay, we still have the y, we still have the a, we still have the b, and we still have the x as an exponent. Okay, I have a couple of examples down here. And then I want to go ahead and highlight the key differences between growth and decay, because like I said, I want you guys to be able to do these problems without a calculator. I want your bookwork to take like 5 minutes today, because you just look at the problems and you say, oh, I know that this is decay because blank. All right, so let's go ahead and figure out how to get those answers. So if I look at growth and I look at decay right here, in both cases, A is greater than 0. So basically what this is saying is that the initial amount has to be a positive number in both growth and decay. So that's not a key difference. Okay? But what is a key difference, as you can see here, is that for growth, B is greater than 1. And what that means is that the middle number right here has to be larger than 1. It can be 2, it can be 5, it can be 100, it can be 1.1 for all we care, but it has to be larger than 1. Okay, and for decay, we want a number that is smaller than 1, but we're not allowed to have any negative numbers. So it's got to be greater than 0, and it's got to be less than 1. So traditionally, we're going to see fractions, we're going to see decimals, and they have to be smaller than 1. And that's what we're going to practice a lot today, doing the bookwork. So if I look right here, we don't care about the initial amount. The only thing that we really care about today is this middle number, this b, because that's going to tell us whether it's growing, like in this example, or whether it's decaying. All right, so let's look at some examples. I went ahead and made some examples for you guys. So you can copy this, you can pause this video, copy this down if you need to. You can try to copy it down while I'm talking, but I don't plan on continuing much longer. Okay, so the two on the left are both exponential growth. The two on the right are both exponential decay. And so what I'm going to do is real quick just talk about how I got these answers right here. And so for all four problems, the initial amount is simply just the first number. And for all the bookwork problems, the initial amount is simply going to be the first number. The letter that we would use to represent these would be the letter A. All right. And so that's how I got the initial amount. Now, the growth factor or the decay factor is a little more challenging. All right. And so what I did was I tried to show you lots and lots of examples. And so let me just talk about these first couple examples for just a minute. So for this problem, the growth factor is the middle number. And since we know it's larger than 1, what we're going to do is we're going to do 2 minus 1, which would be 100%, is equal to 1. And if I convert that into a percentage instead of a decimal, that would be 100%. So what this is saying is that this is doubling or growing 100% every time this time occurs. All right. So what about down here? The initial amount is 1/2. The growth factor is 4 minus 1 is equal to 3, which we could convert pretty easily to 300%. So every time this certain amount of time passes, whether it's weeks, days, years, or months, or whatever, the initial amount is growing 300%, or it's quadrupling. Ooh, that's a fancy word there. It is quadrupling the initial amount. Okay. So what about decay? Well, we know that these two problems are both decay because the middle numbers are less than 1. And instead of doing the number minus 1, we're actually going to do it backwards since it's decay. So what we're going to do is we're going to do 1 minus 1/2, which if you type that in your calculator, it's going to give you 1/2. And then you're going to convert that to a decimal, which is 0.5. And then we know that 0.5 is 50%. All right. And down here, the initial amount is 1/3. And we know it's decay because it's less than 1 in the middle. And so 1 minus 1/4 is equal to 0.75, which we are all capable of converting to 75%. Okay? And so what I'm going to do is I'm not going to talk for very long, so you might need to pause the video. I'll leave it playing for about 30 seconds, and then I'm going to turn this video off because we're almost done. But here's 4 more examples. You're more than welcome to copy these down in your notes, or you can just look at them. And what I tried to do was I tried to pick some examples that we hadn't already seen before, but the process is the exact same. All right, so you've officially survived this second video, so thank you for your time and cooperation. I hope you enjoyed this. We have one more video that you're going to watch after your quiz tomorrow. Good luck.